Hi everyone, my name is Lam Kai Tze, and I'm from Group Meta, and our group leader is Lee Xiang Da, following with the group member Pang Zhen Yang, Lam Kai Tze, and Liu Liang. Now I'm going to explain the maximum likelihood estimation. So for the definition of maximum likelihood estimation is a statistical model's parameter can be estimated using the maximum likelihood estimation MLE approach. The fundamental concept is determine the range of parameter value that maximize the probability function. A measure of how probable is that the parameter value will result in the observed data. Next is the Bayesian estimation. For the definition of Bayesian estimations is a statistical approach where uncertainty about model's parameter is quantified using probability distributions, allowing the incorporation of prior knowledge and updating beliefs based on observed data through Bayesian's theorem. That's all for my part. Thank you.
Hi everyone, I'm Lee Xiang Tak. So just now my teammate Lam Kaiser has some theoretical only discussed with you guys. Now I will share more details about the Bayesian estimation. First, the general concept of the Bayesian estimation is involved by using Bayes' theorem to update the probability distribution over the parameters of the interest based on the observed data. Next, the Bayes' theorem, or we can also call it Bayes' formula, is a fundamental concept in probability theory and statistics. It describes how to update the probability of a hypothesis based on new evidence. Next, which is the Bayes' theorem, or we also can call it Bayes' formula, that we have mentioned just now. The prior probability is used as a starting point for calculating the posterior probability. It represents our beliefs, uh, our aims about the parameters before observing any data. The likelihood probability is a probability that of observed data which given the parameter of the models. The posterior distribution is the updated distribution of the parameter after observing the data, and the evidence is the marginal likelihood or evidence which act as a normalization constant. And that's all for my part, and I will pass to the next one.
Hi, my name is Pang Zhen Yang. Now I will talk about the maximum likelihood estimation. In parameter estimation, the goal is to find the best fitting parameter for a given statistical model based on observed data. Methods like maximum likelihood estimation, expectation maximization algorithm, method of moment, and maximum a priori estimation are commonly used. Among these, MLE is often favored for its simplicity and consistency properties, converted to the true parameter value as the sample size increases. Unlike Bayes' techniques, MLE does not require specific prior distribution, making it simple to implement. However, the choice of method depends on the specific characteristic of the problem and the assumption one is willing to make. So below is the calculation formula about the maximum likelihood estimation. That's all for me. Thank you.
Hello everyone, my name is Liu Liang. So now I'm going to present about the difference between MLE and the Bayesian parameter estimations. The first is the philosophy. The philosophy of MLE is the parameters are fixed but unknown, and for the Bayesian is the parameters are treated as random variables with prior distributions. And the second one is about the objective. The objective of MLE is to find parameters values maximizing likelihood functions. And for division is to obtain posterior distributions of parameters given data. And the interpretations, the MLE parameters are estimated as most likely values given data. And the Bayesian parameter described by posterior distributions updating beliefs after data. And for the uncertainty, the MLE typically does not quantify uncertainty in parameter estimates. And for the Bayesian, it provides full probability descriptions. And the computational complexity of MLE is simple, and the Bayesian is more complex due to posterior calculations. The last one is the applications. The MLE commonly used in frequency statistics and machine learning. And for the Bayesian parameter estimation, it's widely used in Bayesian statistics, decision theory, and Bayesian machine learning. So that's all from my part. Thank you.